Hello everyone, in this video we're going to look at the basics of object-oriented programming in Dart. So first of all, we'll start off with the motivation. Why do we need to use object-oriented programming? So we've looked at how to create primitive data types, so things like strings, numbers, booleans, and so on. If we want to create a string, for example, we'll say string name equals to Mohammed. Now what if we want to create our own custom object or data type? Let's say, for example, we're building an application that needs to display a list of athletes, and every athlete has a name and a team. So for that, we need to use classes. So let's create a new class and call it athlete. And every athlete will have a name and a team. So we'll say string name and string team. Now for now, I'll just make them optional, so these parameters could be null. Next, if we want to create an object of this class, we will say athlete Salah is equals to athlete. And this is how we create a new instance or a new object of the athlete class. Now, every instance will have these two instance variables or properties. So if we say print Muhammad Salah dot name, and then we can copy that and print Muhammad Salah dot team. Now if you print this, it will print null because these values have not been initialized yet. Now what we can do is we can say Muhammad Salah dot name equals to Muhammad Salah. Then let's copy this, paste it here, say Muhammad Salah dot team is equals to Liverpool. Now if we print this, it will print the name and the team. Now instead of doing this manually afterwards, classes give us a constructor function, a function that is called whenever we create a new instance. This function will have the same name as the class. So we'll say athlete, and then here we'll say this dot name and this dot team. Now here you see this keyword, and this references the current instance. So you can think of it as a shortcut of doing this. So rather than doing the instance variable dot name or dot team, we use this instead. Now I can remove this, and then I can pass in Mohammed Salah here, and then Liverpool. So these parameters will be passed into the constructor function. The name will go as the first argument, and the team will go as the second argument. Now once we have this, we no longer need the question marks, so these values will no longer be optional. And if we run this, it should print the same thing. Now let's see how we can create another instance. So let's copy this, paste it, and for this time we'll say Kyrie Irving, and the name will be Kyrie Irving, and the team will be Brooklyn Nets. And now what we can do is we can copy this, paste it here, and then say Kyrie Irving, copy this, paste it here, and you'll see that it will print out Mohammed Salah for the first one and then Kyrie Irving for the second one. Now we can also define methods. So under here, let's create a function called shoot, and what this will do is print shoot the ball. Now what we can do is say Mohammed Salah dot shoot, and then Kyrie Irving dot shoot as well. If we print this, you'll see it calls shoot the ball for both. Now let's take this one step further. What if we want to have a separate soccer player object and a basketball player object? However, both of them will still have a name and a team, and both of them will be able to shoot. But for the soccer player, when we call shoot, we want to say shoot the soccer ball. And for the basketball player, when we call shoot, we want to say shoot the basketball. So for that, we will look at inheritance. So let's create two new classes. So one called soccer player. And this time we want to extend, so we call extends athlete. And we'll create another class. This time will be basketball player. Now we need to create constructor functions for them. So for soccer player, I'll copy this. And then here I'll say taking a string name and a string team. And notice that here I'm not calling this. Now what we need to do is take these arguments and then call the superclass's constructor function. And to do that, there is a super keyword. So if you call super, this references the superclass. So the superclass is the class we're extending from. So I'll call super, and then I'll pass in the name and the team. So if you notice that when we call the soccer player constructor, we're going to take this argument right here, and then we're going to pass it in the athlete constructor. The name will go in as the first parameter, and then the team will go in as the second parameter. And now when we create this object right here, rather than using athlete, we'll use soccer player. So say soccer player. And then this will be soccer player. Now let's do the exact same thing for basketball. So basketball player. And now here we will say basketball player, basketball player. Now when we run this, we'll get the same output. So you'll notice one thing. We have not defined the shoot method under these classes. However, we were able to call MohammedSalah.shoot and KyrieIrving.shoot because we inherited from the superclass. Also, we didn't have to define these instance variables again. So you can see that we're not defining these properties on the subclasses. We're only defining it in the superclass. Now let's see how we can overwrite this shoot method. So let's say we want to make the soccer player call shoot the soccer ball and the basketball player say shoot the basketball. So we can just redefine the methods. So here I'll say shoot. And here I'll say shoot the soccer ball and say shoot the basketball. Now if we run this again, you'll see that it calls the shoot method of the subclass rather than calling the shoot method of the superclass. Now let's say we still want to print shoot the ball. What we can do is say super.shoot, and here as well we can say super.shoot. And what this will do is print the method from the superclass first and then continue by printing the method from the subclass. Another thing to note is that whenever we are overriding methods from the superclass, it's useful to have an override keyword or annotation at the top. So we can say @override. Now this annotation is optional and it does not affect the program execution. However, the Dart analyzer uses this to give you warnings if there are any issues. So for example, let's say we renamed the method from the superclass and we called it shoot ball. Now the Dart analyzer will recognize that this no longer overrides a method from the superclass, so you should not be using the override keyword. However, if you don't have this keyword, the method will still override the method from the parent class. So let's look at how we can add object-oriented programming to our application. So we'll see that in the next video.